So here we have the checklist for quantitative chemistry inside the part of the whiteboard labeled quantitative chemistry. To the right, you've got loads and loads of pages from your specification, loads of mind maps, and you've also got lots of different tests with the answers all on quantitative chemistry. Clearly, we don't need those columns there because it's chemistry, and we don't need that column there because, of course, it's quantitative chemistry. But there's your tests and your answers. Let's go through what this checklist is saying. So first of all, know what is meant by conservation of mass. What that means, so the highlighted ones are the keywords. So conservation of mass is like a key term. You can't really call it a keyword because it's 3 words, but it's a key term. So it's a conservation of mass is that if I were to, let's imagine I did an experiment where I took some, let me think. I've got a beaker of water. Oh, let's use a different color. I've got a beaker of, well, let's say I got a beaker of acid. All right, so in there we have hydrochloric acid, which the symbol is HCl. And I'm going to put inside of it some magnesium. Okay, so this is Mg. And what you're going to get is you're going to get lots of bubbles. And these bubbles, you may not know it until you do. Well, first of all, we won't know what the bubbles are until we learn about chemistry. And so what's happening? We've got the magnesium reacting with the hydrochloric acid, and that's then making magnesium chloride and hydrogen gas. Now, actually, this thing is going to help us tick off a few things. But first of all, I will just simply start off by saying that's a mistake. This is unbalanced. We're going to look at that in the second part of what we're going to do. So, but let's imagine we got all these bubbles. Now we can see the bubbles are actually hydrogen gas. So this bubble here, this is actually hydrogen gas because my equation shows me that I'm producing a gas, hydrogen gas, and that must be what the bubbles are. Now, if I were able to catch all these bubbles and then weigh all the hydrochloric acid and weigh all the magnesium, I will find that the mass is unchanged, or we can say the mass is conserved. So the mass doesn't change before or after the equation. Okay, before or after the reaction. It does. Now, it will look like, when you do the experiment, it will seem as if the mass is going down, but that's only because you're losing some of the hydrogen gas to the air. So if you put this on a scale, on like a weighing scale, and just let it fizz away, you'll look at the scale and it'll go down. And then you think, well, that's strange because, yeah, that's right. So like the case with the example you gave of a balloon, if we stopped those particles from escaping from the balloon and going off, then and we kept all that on a scale, the mass will not change. So the mass is conserved. So that is conservation of mass. All right, I'll just stop that video.